Hi, my name is John Ackermann, N8UR, and I'd like to talk to you today about TAPR, an organization that I've been involved with for many years and that I think is one of the most interesting in ham radio today. TAPR is a community that provides leadership and resources to radio amateurs for the purpose of advancing the radio art. We really promote the technical side of the hobby, and that language, advance the radio art, comes from the FCC regulations about the basis and purpose of the amateur radio service. And we want to be among the ones who are promoting that area. We do that by providing hardware and software that doesn't yet exist in the ham community. We focus on early development of new types of technology. Once it becomes mainstream, we've typically moved on to something else. We, in addition to providing hardware and software, try to spread information and knowledge about this new technology. And we do that through conferences and forums. We've been sponsoring the Digital Communications Conference along with the ARRL and ancestors of that conference since 1981. We've had a major presence at the Dayton Hamvention since at least 1983. We've sponsored mailing lists on the internet for special interest groups or SIGs since 1992. And in 2020, we're going to have the first virtual digital communications conference, and I hope that we'll see many of you there. Before talking about what TAPR has done, I'd like to talk a bit about what we're doing now because I think it's really exciting and shows how we are on the cutting edge of ham radio technology. TAPR has been working with the HamSci organization on a new hardware project called the Tangerine SDR. HamSci is an informal group of space scientists working with amateur radio operators to use ham radio as a way to provide further data for understanding of the Earth's ionosphere and magnetosphere and what's called space weather. HamSci got its start with the solar eclipse in 2017 and sponsoring a QSO party, with the idea being that the logs that were generated by that, as well as the digital communications, PSK31, FT8 type transmissions, could be used to get an understanding of what happened to radio propagation during the eclipse. And in fact, that worked really well. There have been several scientific papers published based on the ham radio data from that event. HamSci is a coalition. It's not a formal group, and it's mainly space scientists, physicists, and ham radio operators who are exploring this thing called space weather. As I mentioned, the first activity was gathering data from the 2017 eclipse. The coordinator of the group is Nathaniel Frizzell, W2NAF, who's now a professor at the University of Scranton. Nathaniel has received NSF funding to develop a ham science data gathering system that includes the personal space weather station. The Tangerine SDR that TAPR is developing is the core component of the PSWS. And I want to make it very clear, TAPR is collaborating with HamSci on this project, but they are two separate organizations, and each is completely independent of the other. Some people have thought that HamSci is a creature of TAPR, and that's by no means the case. They're separate and independent groups that are finding a lot of synergy in working together. The Personal Space Weather Station is a new software-defined radio, and this is a block diagram of the radio as well as its surrounding components. It's an HF-based receiver. The performance is similar to that of the current radios that are available from a number of manufacturers. It's built off of the design of the open HPSDR radios, Hermes, and successors that were sold by Apache Laboratories as the NN series radios. But it includes, in addition to the radio component, a large field programmable gate array, which is a computational engine with lots of logic gates that can be programmed to do all sorts of high-speed parallel processing functions. And that FPGA is used to manipulate the received data and reduce it into forms that can be used for other purposes. It includes a GPS-DO for precise timing and frequency information. There's an optional magnetometer because magnetic field information is an important part of space science. And all that feeds to a client computer, either a single board computer or a desktop for the local user. And it's important to note that this system is designed for science use, but it's also a ham radio. And it can be used as a ham radio, and that local display gives access to the user for all of the normal radio functions. In addition to the local activity, the data that's collected by the personal space weather station can be uploaded to the internet, either automatically or on demand, where it goes into a public database that's accessible to researchers who can call up the data to examine events that occur in space weather. So if there's been a big solar flare, for example, the scientists will be able to go out and solicit data from all the PSWS systems that might have been on the air during that time to see what happened to propagation as a result. The project is a modular open source hardware and software platform, and it's going to be a complete system for software-defined radio. And it's also a group of volunteers led by TAPR who are dedicated to the idea of building a pool of open source software defined radio design information so that this can be a modular system that can grow over time and not just be a single static project. It incorporates some of the concepts of Open HPSDR. It has some of the philosophy of the Open Research Institute, and it has the same kind of scientific purposes as HamSci, but it's not any of those things. Tangerine SDR is really its own creature. The radio itself has some basic features that should be attractive to hams. We're trying to make the cost comparable to other SDRs today. Depending on what hardware is included in the system, the lowest cost could be $300 or so, or it could be $1,000 or more. But because it's a modular system, the user can customize to get those prices to match the performance that they require. It's based on open source, and this is really important. Both the hardware and the software are licensed under an open source model, so others will be able to take this design and advance it and make it part of bigger and better systems over time. It's designed to be extremely modular, configurable, and expandable, and above all, it advances the state of the radio art, which is TAPR's primary focus. It has a number of target applications. We've already talked about the HamSci Personal Space Weather Station. It also may find a place in the AMSAT Phase 4 satellite ground station as the digital processing engine. It has academic uses to teach SDR and FPGA techniques. It can be used, very importantly, as an amateur radio communications device. It is a ham radio, after all. It can also be used beyond ham radio for non-amateur types of applications and RF monitoring. Because it's internet-based, it could be used for remote ham radio stations, and certainly there are many other possible applications that people will find for this system. Now, shifting gears to talk a little bit about TAPR itself. Uh, the organization was founded in 1981, and you may, if you've been around for a while, know us as the folks who brought packet radio into prominence. In 1981, a group of hams in Tucson developed the first popular packet radio hardware called a terminal node controller, or TNC. And that's where the organization got its start and where it got its name. The only problem with that name, Tucson Amateur Packet Radio, is that today we are much more than just in Tucson. We have board members from around the world, one in Australia. Our products are used not just in ham radio, but in colleges and national standards laboratories. Packet is just one of the modes we support. And although we're definitely a ham radio group, the things we do are not all related to ham radio or even radio directly, but they are in the allied fields of digital communication and signal study. We're a nonprofit 501c3 organization, and our dues are 30 years and open to anyone. Because we're a nonprofit, your contributions are tax deductible, so keep that in mind. We publish a quarterly journal called the Packet Status Register, and our main website is at www.tapr.org. Organizationally, we have an annual membership meeting at the Digital Communications Conference, which this year will be virtual. Uh, we have a 9-member board of directors who run the organization. The directors are elected by the members, usually by electronic means, following nominations that are made at the annual meeting. There are 3-year terms, and each year 3 directors are up for election. We typically have 2 physical meetings yearly at the Dayton Hamvention and at the Digital Communications Conference, but of course this year that's all different. And I think perhaps uniquely among organizations, we've been continuously uh, in our board meeting sessions since the 1980s via email, and even before email via CompuServe. Our bylaws are structured so that we can do business completely by email, and we transition from the online session to the physical session when we have our meetings at Hamvention and DCC, but we're in continuous session, probably a world's record for the longest board meeting in history. The president of TAPR currently is Steve Bible, N7HPR. Vice president is Scotty Cowling, WA2DFI. The treasurer is Tom Holmes, N8ZM, and our secretary is Dana Horzepa, WA1LOU. TAPR is largely about the products that we've created, and those products sometimes have been kits of components, sometimes they've been finished electronic components, sometimes they've been software, sometimes they've been publications, but they all have a set of common themes. One is that our history has been on the bleeding edge of technology in ham radio. Our goal is to provide kits and assembled products that enable new technologies that simply aren't available elsewhere. Most of our revenue and our operating funds come from product sales. So those product sales fund the new products that we work on, and therefore are a very important part of our operation. And we encourage you to visit the TAPR store at our website and buy lots of things, because each time you do, it helps us move forward. We're very much an engineering-led organization. There's that old chestnut of he or she who codes rules, and that's a bit of the way we operate. If you come to us with an idea that's ready to be taken forward, you'll get a welcome of open arms, and we really are enthusiastically looking for folks who want to help us with new products and new designs. We have a very strong bias toward open source hardware and software. Virtually all of the products that we do today are licensed under open licenses, which allow others to not only make but also enhance them. And one of the things that the TAPR is good at is providing development support. We are not a bunch of people in lab coats thinking up ideas and bringing them to market without outside input. We are a bunch of people who have done some of that, but we also have the knowledge of what it takes to take an idea and turn it into a buildable, reproducible, and ultimately sellable design. We encourage people who have ideas for products that fall within the general scope of what we do to come to us with proposals, and we can provide development support to go from the prototype to the marketable stage. And we're always looking for the next big thing. We never rest on our laurels. As we work in one area of technology, we're keeping our eyes open and looking around for what is the thing that's going to impact amateur radio after the current one. So where we started, I mentioned before that packet radio was really our pioneering application. And in 1982 and 83, TAPR developed and sold the TNC1. And in 1984, I introduced the TNC2. And you, if you've been in packet radio, have probably either used or talked through a TNC2 clone TNC, because those designs were licensed to a number of manufacturers, including MFJ, PACCOM, and others, and were produced very widely for many years. So TAPR really is at the beginnings, and our hardware was the kind of core hardware of packet radio during the sound card days. So we really look back to the TNCs as our first products, but we very quickly moved beyond that. And I think you'll see some of the other things that we've done as I go through these next slides. Um, in packet radio, in addition to hardware, we helped with documentation and standard writing. In 1984, working with Terry Fox, WB4JFI, and the AMRAD organization, who were really the prime movers in this. TAPR was a facilitator. We published the AX25 version 2 specification, which is an important milestone for standardizing packet radio. In 1990, Phil Karn, KA9Q, published a protocol called MACA for multiple access with collision avoidance that's become part of packet radio activity. And in fact, his presentation was used to help defeat a patent that someone tried to get on the MACA concept later. In 2000, uh, Ian Wade, G3NRW, Greg Jones, WD5IVD, and I worked with the authors of the APRS software to develop a protocol reference specification, which again was a very important step in standardizing the APRS system and making the software interoperable. So we've been involved with developing packet radio standards on the air as well as the hardware that implements them. After packet radio, TAPR was an early proponent of spread spectrum radio. We published books on the subject, and in the late 1990s worked on a 900 megahertz spread spectrum radio called the FHSS radio. It was a tremendous piece of engineering by Tom McDermott, N5EG, Bob Strickland, N5BRG, and Bill Reed, WD0ETZ. But unfortunately, the parts that we were using kept being made obsolete by the manufacturers, and we weren't able to get a design that was stable long enough for us to be able to manufacture it before the parts were no longer available. So unfortunately, the FHSS radio never made it into production, but the learning from it has impacted future designs and was a very important aspect of the early understanding of how to do spread spectrum and ham radio. We also were involved in those days in 1998 in GPS as it became popular. And GPS has a couple of different applications. One of them that isn't as well known as the navigation purpose is timekeeping. A GPS receiver can generate an extremely precise 1 pulse per second time signal that's locked to the national time standards. And this is really important for a lot of applications such as radio astronomy. Tom Clark, W3IPI, led a team that developed the TAC2, which was an interface board for a Motorola GPS module that provided the signal connections needed and also some software to allow that GPS pulse per second signal to be used for timekeeping in a number of scientific as well as ham radio applications. And that was the first timing product that TAPR did, but as you'll see, it was far from the last. But the TAC2 led not only to a long line of products, but also a naming convention that a lot of people will recognize as I talk about some of the other products that we've done. In addition to GPS for timekeeping, there's GPS for precise location. And in 1998, Doug McKinney, KC3RL, who's unfortunately passed away, and Steve Bible, N7HPR, did a differential GPS reference station that was allowed or designed to allow a very high accuracy GPS location within range of a base station that essentially told the GPS how to compensate for inaccuracies in the satellite signals. And at that time, that was another first for a low-cost, readily available DGPS reference station done by Doug and Steve. As we move toward what's now the broad and very popular area of software-defined radio, once again we find TAPR engaged in the very early days. In 1999, Motorola had an evaluation module of a very powerful DSP, digital signal processing chip, and Johan for K7WW, Steve N7HPR, Lyle Johnson WA7GXD did an interface around that board that provided the various signals and connectors needed to make it usable as part of a radio system. And the DSP 56002 interface was one of the first ways that hams could start working with software-defined radio technology, and was an important groundbreaker in that field. Tom McDermott, N5EG, wrote a book on digital communications design and theory that talked about modulation techniques and how to implement digital communication systems. And that book was sold through TAPR and became a very standard textbook used in many college and technical programs. That book is still available today, although it's a bit old, and some of the examples perhaps are. The basic underlying knowledge is still valid and still very useful. So if you'd like, we still have that book available now, and we thank Tom for making it available. It really has helped educate a lot of people over the years. After the DSP evaluation board, we moved up to the first true SDR for hams, the DSP-10 by Bob Larkin, W7PUA, in 1999. It used an evaluation module to provide the IF, but was tightly integrated with the rest of the radio front end and provided a 2-meter SDR with PC control that would be recognizable to you today who are using SDRs in your ham shack. And that was 21 years ago. I mentioned our long history in time-related activities. Sometimes we abbreviate that to Time Nuts. There's actually a mailing list with about 2,000 people that's called Time Nuts. I got involved in that area many years ago and found that there were lots of little gadgets that I needed in order to build up my time measurement laboratory, and everything that I designed sort of turned into a TAPR project. So we started with the TAD, which stands for Totally Awesome Distribution Device, which was an amplifier for 5 and 10 megahertz oscillator signals, and added a whole bunch of products. I think there may be 10 or 11 total today that have been designed in the timekeeping world: buffer amplifiers, distribution amplifiers, dividers, switching systems that have all found places not only in amateur stations, because most of these do have ham uses, but also in scientific and educational organizations as well. Along the way, there was an interest in developing a model where hardware designs could be protected from being taken proprietary after volunteers have worked on them. And a group of developers on a project that I'll talk about in a bit asked us to develop an open hardware license that was sort of like the open source software licenses. And in 2006 and 2007, we worked with a number of volunteer contributors to design a license called the TAPR Open Hardware License. It was formally published in 2007, and it is a widely used license for open hardware today. So we've helped to bring the concept of open design from the software world into the hardware world through this license, and a number of other organizations have adopted it as well as TAPR. Now we get to the first real ham SDR, something that works on HF and is fully flexible. The high performance software defined radio project is the one for which the open hardware license was created. And starting in 2009, a system that was based on a plug-in bus that we call the Atlas bus was developed. And this picture is a homebrew showing that bus with our receiver and transmitter boards, a control module that talks via USB to the host computer, an antenna switch and high pass, low pass filter module in the middle, and a 20-watt amplifier that makes a complete HF station that went from 100 kilohertz or so up to 56 megahertz. with a half watt output, ultimately with the amplifier about 20 watts output, as a complete station. As you can see, this is sort of an experimenter's design, and that was refined a bit later, as you'll see in a moment. We also were working on the software side of radio, and one of the big issues is that all of the digital voice systems, things like Ambi, that are popularly used for voice communications, are patented, and hams simply couldn't go out and write their own code to implement them. They had to buy a chip from someone. And in order to get around that problem, David Rowe, VK5DGR, decided to develop a codec, which is the name of the software that converts speech into digital compressed voice signals. Uh, and to try to develop a codec that did not have any patents covering it, and that would provide very good quality, communications quality speech at very low bit rates. So you can transmit with codec to a digital voice in really about the same bandwidth, sometimes even less bandwidth than a regular analog sideband signal would take. And TAPR supported David, and we're very happy that we've been able to assist him as he developed this software, which is available freely as open source to all comers. So that's a project that TAPR did not lead, but we supported, and we still support, and we think really helped advance the state of the amateur art. Another aspect of digital communications on HF is Whisper, which is a protocol that allows very low powered transmitters to be used as beacons to check propagation around the world. And Zoltan HA7DCD designed a small transmitter board that plugged into a Raspberry Pi and made a complete standalone Whisper transmitter. And TAPR started selling that in 2015. Since that time, we've added additional bands. The original one was 20 meters, but now thanks to efforts from Bruce Raymond, ND8I, we have units for 40 meters and other bands as well. And these are very popular, very low cost ways to put beacons on the air that allow for propagation experiments and actually feed into the HamSci network. Now back to time nuttery, a recent project shows the power of modern single board computers to get performance that simply wasn't available elsewhere for sometimes any price, but certainly for a very high price. There's a need in the timekeeping community for a timer or counter that can measure with a resolution down in the millions, billions, or trillions of a second. And the TIC is a design that I came up with a few years ago that used a new chip that was made available by Texas Instruments along with an Arduino, a single board computer, to implement the entire counter with 60 picosecond, and that's 60 trillionths of a second timing resolution. And because it's built on the Arduino and uses low-cost parts, we're able to sell the unit for about $200. To buy that kind of performance prior to the TIC, you had to spend many thousands of dollars and sometimes tens of thousands of dollars to get that kind of resolution. So the TIC was a real breakthrough, and it's been extremely popular. We sold over 400 of them. They're used not only by hams, time nuts, and other amateurs, but by national standards laboratories. We know for a fact that there are TICs being used to monitor hydrogen maser frequency standards in laboratories around the world. And it shows how modern approaches to technology can get performance that in the old days would have been much larger and dramatically more expensive to something that today we can put in a hobbyist's workbench very easily. And in fact, if one TIC is good, 8 of them, or rather 4 of them with 8 channels are better. And just as an example of how we can extend things, these pictures are of the multi-TIC, which is 4 TICs connected together to work as a single unit and allow 8 channels of measurement. You normally wouldn't need that, but I was testing a whole bunch of GPS receivers for their pulse per second signals, and having 8 inputs was actually extremely useful. So that led me to put this together. And again, it's a capability that either wasn't available at all or would have cost tens of thousands of dollars in the past. And in this unit, it's fair to say that the uh, one-off metal work was the most expensive single part of the entire design, because the hardware itself was quite inexpensive. So that's an example of the things that TAPR has done in the past, a little bit about what we're currently doing, and the question is, what's next? And I'd have to say, what's next is completely up to you. We'd love to hear from you, and we'd love to try to turn your idea, the back of your napkin, into the next big thing for ham radio. But before I finish, let me talk about some of the other things that TAPR does away from products and development. As I mentioned at the beginning, we sponsor the Digital Communications Conference each year, as well as other activities to help spread knowledge within the ham community. We've been at the Dayton Hamvention since 1982, and we will be back next year when it's live again. We have a booth there, and we also have a forum at which we have presentations about current projects and activities that are going on within TAPR. And I've also mentioned the Digital Communications Conference, which this year is going to be a virtual conference. It was originally going to be in Charlotte, North Carolina, but because of the COVID-19 problems, we shifted to digital and will be in Charlotte next year in 2021. The 2020 DCC is on September 11th and 12th. You can register at the TAPR store, and there will be a Zoom conference with a nominal registration fee that will allow you to interact and ask questions. There's also going to be a free YouTube stream available for those who don't register, but registration will not only support TAPR, but also allow you to participate in a greater way. So please visit www.tapr.org/DCC, and you can register for this 2-day conference coming up in September. And now, finally, I'd like to talk about some of the folks that have made TAPR what it is and some of the awards that they've won over the years, because it's really quite remarkable what has come out of the TAPR organization from an awful lot of people over quite a few years. Matt Edis, N8UR, won a college student paper contest that we had. And he went on to create Edis Research, which is now a subsidiary of National Instruments. And he really came up with the first software radio appliances, which are general purpose, high performance SDRs called the USRP, which stood for Universal Software Radio Peripheral, which are widely used around the world in science, industry, education, he first talked about software-defined radios, and he first showed off his USRP at a TAPR event. Gerald Youngblood, who's the founder and CEO of Flex Radio Systems, did a 3-part article in QEX called A Software-Defined Radio for the Masses, in which he described what became the first generation of Flex radios. And he presented a presentation and showed off the first SDR 1000 boards at the 2002 DCC in Denver. And you might have seen what Flex Radio has turned into and what they've done. It's really quite amazing. In 2014, Gerald gave a presentation at the DCC about how Flex Radio came about as a result of his work as an amateur. And the link is here and very much worth watching. Bayan Garabrand, N6BG, was an active participant in APRS, and he was a TAPR board member who later created Bionics and sells lots of APRS related products. We've won awards for a number of articles by TAPR people. In 1995, Steve Bible and Greg Poole wrote about amateur radio on the World Wide Web and won the June 1995 Cover Plaque Award for what's really the first description of how the web can be used for information exchange about ham radio. Quite forward thinking 25 years ago. Many Dayton Hamvention Award winners have come through TAPR, have been TAPR volunteers, officers, participants from 1984 through 2016. It's a very impressive cast of characters, and we're proud of them all. So in closing, we'd like to really ask what TAPR can do for you, and you can tell us that by reaching out by email to our website. If you have ideas for products related to any aspect of digital amateur radio or digital technology, we'd love to talk to you, because again, we're always looking for new ideas and new ways to advance the state of the radio art. And with that, I will stop and say thank you very much. I appreciate your time, and please visit the website and please reach out to us. We'd love to hear from you. Thanks.